All right, so Module 10 has titrations, and in the titration, you're going to be picking where you are in a reaction. And where you are is going to match with different ice chart methods we've already learned. I'll show you that in just a second. There will be 4 stages, and then also you'll look into titration graphs. So that looks like this. So here's some titration graphs. A titration is where you're dripping liquid into a container. It's got like that, that little, it's like a little turning knob. And it's a real long tube. It's a burette. This section is a burette. Those are titrations, where you're dripping something in slowly to something else. Now, a titration has 4 stages. It's depending on the type, and I'm going to jump to the one that has more parts. So the weak acid titration is the one that has 4 stages. It starts off with either a weak acid or a weak base. And so that means that a titration starts off with that, with what you learned at the end of Module 8, or the second half of Module 8. So that's how an ice chart starts. And then that's stage 1. Stage 2 is then an ice chart goes into being, a titration goes into being a buffer. So if it's stage 2, then you treat it like a buffer using that Henderson-Hasselbalch equation. If it's stage 3, then you treat it like a salt. Remember, this is the one where it's like the acid, except there's the extra little part right here that you have to flip things around. And the equation can sometimes feel a little funny to write until you get used to writing it. But you've already learned all of that. And then finally, the last stage is you'll have a strong base or a strong acid, which actually goes all the way back to before the last test. Strong acids or strong bases, these are 2 strong bases. You end up calculating molarity of OH or of H3O+, and then you just plug it straight into the equation. So you can bypass an ice chart when you're in that final stage. So that's what the titration's about, is recognizing what stage you're in and then using the right option, basically, or the right method for it. So again, it's not anything new. You've done all of these already. It's just now you're using them in different scenarios. And then finally, we are moving into insoluble salts. And this is the last time that you're going to be dealing with ice charts. So we go back to ice charts. The great thing about insoluble salts is that the math is usually a lot easier because you don't include solids. And so this whole section is blank, which is great. These both start at 0, and so you just end up plugging, like x squared in, because this is x and this is x. And then you either just take the square root of this, or if you know x, you can just square it and you get the case b. And even when you have like a coefficient, like a 2 in front of that, it still isn't too crazy. I don't have an example that has a 2 in it that'll work immediately. It doesn't turn out too crazy though. It's just you still would have an exponent. So like I said, you couldn't have a 2 there because there's not a 2 there. But if you did, it just gives it an exponent. But even in that case, it's just 2x squared times x. So again, it's not like all these extra numbers are involved. So that's really a nice feature of the salts. And then that's the first stage of the soluble salt ice chart. And then there's a common ion. And all that one does is make the math even easier because it just means that there's a number here. And if there's a number there, you can assume that this x over here is really small. So it means when you're plugging in for the AG, like let's say that the number right there was a 0.1, it just means that for the AG, you're plugging in a 0.1, and then for the CL, you're plugging in an x. And hopefully you're seeing that's even easier math than having to ever take the square root of something. So that's a common ion. And then the last one is Q versus K. Lost my Q somewhere. Q versus K. Now look, you've done this before. This is not a new concept, but it was way back when you very first started ice charts. Way over here. Look. Q versus K. This was in the equilibrium section where you could decrease concentration or increase, and it shifted away or from. And if you had the Q and it was like that, it increased to products versus increasing to reactants. So you've already learned that. That same principle is completely there. The twist on that one is that you will actually be doing a reaction. And if you'll notice my colors, I have one thing that's aqueous, and we're not, this is the insoluble salt section, so we're really only looking at the insoluble part of this. So we're looking at him, and we already know like that's the KSP, so that's also the QSP, let's say. So the way that this works is that you actually use the numbers that come and you fill in real numbers to get an actual value here. So you'll see I color coded this. The AG part, this is this AG, but the AG part of that has a value of 0.1. So hopefully you can see I've kind of color coded all of them. That has a value of 0.1. And then the CL, see he comes from the NaCl, that has a value of 0.2. So you just multiply those and then you get a Q value. You look it up, you look up the K or it's in the problem and you compare. So you'll see these, you'll see how to work them coming up, but that's that method right there. And that's module 10. And like I said, after the test next week, we're moving on to electrochemistry. We are not touching ice charts again until I guess the final, but you just got to get through this little section here.